Hello and welcome to this presentation of the TrainerDoc Sports Tracker product. This project was done in collaboration with Dr. Hoover, Jacob Weller, and Dr. Duffy, whose product, the TrainerDoc, pictured here, is a kick training tool for youth soccer players. We use the ME Nicholas Sense Arduino to gather our data, and a goal of the project was to create a more affordable product than the ones already on the market. Here is the Arduino. It is equipped with an accelerometer, a magnetometer, as well as pressure sensor and temperature and humidity sensors. And we chose to use pressure as our mode of testing because it was more accurate and easier to gather and process the data. And as mentioned previously, due to the scope of the class, we did a proof of concept, and more work needs to be done in the future. It can possibly be passed on to future ME41 classes till its completion.
The test plan for our project was relatively simple. In order to determine the accuracy of our digital sports tracker, we ran a series of tests using the TrainerDoc Perfect Kick Trainer and compared the number of kicks recorded by the digital sports tracker to the actual number of kicks. For each trial, a member of our group juggled the ball for a certain amount of time, and the rest of the group counted the number of kicks. The pressure data from the digital sports tracker was recorded, and a MATLAB script was used to estimate the number of kicks from the pressure data. Before we could begin testing, we first had to develop the hardware and software for the digital sports tracker. On the hardware side, we were provided a Nicholas Sensme Arduino and a lithium polymer battery from Jacob Weller. To assemble the digital sports tracker, we soldered the battery to the Nicholas sensor. On the software side, we used the Arduino Integrated Development Environment (IDE) to upload a sample program that allows the Nicholas Sensme to communicate via Bluetooth. We then modified a program from the Arduino GitHub page to create a BHY controller. This controller creates a local web server to configure and receive data from the Nicholas Sensme via Bluetooth. A screenshot of the web server can be seen on the left. The pressure data from the sensor is saved to the console log on the web server, which can be accessed after each trial. We then wrote a MATLAB script to parse the sensor data and estimate the number of times the ball was kicked. For the experiment setup, the digital sports tracker was placed in a pressure chamber. An air hose was then connected from the pressure chamber to the needle valve of the ball. This assembly can be seen in the picture on the right. For each trial, the person kicking the ball held the strap of the perfect kick trainer and pressure chamber in their hands so that the air hose stayed connected to the strap. This way, the air hose did not get tangled while the ball was being kicked.
Data for our project was collected real-time from the Arduino using an internet dashboard. Results were saved as a text file and went through post-processing using a custom MATLAB code. The MATLAB code was capable of taking the acquired result and running 4 tests to count the number of kicks and check for accuracy. The first method was to find the local minima and maxima to determine the location of each peak and take the relative difference between the minimum and maximum values for the peaks. The relative amplitude was then checked to fit within a minimum and maximum floor to eliminate noise. The second method used the root mean square of the data to create a minimum floor, and any peak found to exceed the root mean minimum square threshold was deemed a kick. These two methods were performed on both the raw data and detrended data, resulting in 4 total methods of kick counting. A total of 9 tests were performed, varying both the experiment time and test subject. Overall code counting errors were recorded as a whole with respect to each person and with respect to the total experimental time. For anonymity's sake, names were removed from the study, but a total of 3 people performed the test for 15, 30, and 60-second intervals. Here is what should be a video of someone juggling the soccer ball as a replica of what the test experiment should look like when performed properly. However, when converting from PowerPoint to VoiceThread, the video component does not appear to work. The budget for the project is not fully vetted here, as many of the components used in this experiment were purchased prior to our testing. However, rough estimates of cost come out to be a little over $100 based on current market price of some of the components used. The materials that were used in this experiment are described here. The controller program and custom MATLAB code are available upon request and can be found in the appendices of our report.
For this experiment, the safety and risk factors were minimal. The most hazardous aspect of this experiment was the juggling of the perfect kick trainer. To prevent anyone or anything from being hit by the soccer ball, proper precautions were taken. The handle of the perfect kick trainer was worn around the wrist of the person kicking the ball as a safety precaution, in case the user dropped the strap. Additionally, all testing was conducted in an open area away from other people and valuable objects.
Table in the slide presents the raw data for the 9 trials performed, as well as the methods used for detecting the number of kicks and their respective percent errors. The highest percent error values are found primarily in minute-long trials. The highest overall percent error is obtained from the raw root mean square readings exceeding 125%. The trended relative peak height error method has the lowest percent error for all 4 methods. Lowest average percent error of 4.3% was found using the D-trend relative peak height, and the highest average percent error of 47.2% was found using the raw root mean square. Between the individuals performing this trial, the highest error and lowest error were found in person 1 and 3 respectively. From the result, it is determined that method 3, D-trend relative peak height, was the most accurate with an average off-kick count of 1.2 and an average percent error of 4.3%. As shown in the previous slide, the D-trend root mean square had the highest average off-kick count of 10.7. There were 10 cases where the kicks detected were the correct value, 8 cases where it was over, and 18 cases where it was under. The average off-kick value was around 6.7.